Now, let's talk about exponent functions for a little bit, okay? Now, let's say, for example, we're just looking at example 2, okay? Um, let's say that, let's call this dollars, okay? Let's call this dollars. Okay, and let's say it's 12,000. Okay, so let's say you invest $12,000 in a bank and they give you an interest rate of 8% per year, which is, if there's a bank that gives you 8% per year, that is freaking legit. Okay, that is super good because it averages around point something percent. Okay, now, so after the first year, you're going to get 0.08 dollars. I'm sorry, I misspoke. You're going to do 0.08 times 12,000 to get how many dollars increase, how many dollars of interest you got from that bank. Okay. And then you got to add, okay, if you want to find the total that you got, then just do 12,000, your initial value, plus that. Okay. Okay, so 12,000 is your initial value. This is how much you got in addition to the initial 12,000 in the first year. Okay. Now, let's say that you want a shortcut. Here's a shortcut. Watch this. I'm going to GCF a 12,000 out. Here's a shortcut. Okay. Because when you distribute this, you basically get the top. Okay. All right. And now let's just simplify this, and you get okay. And that's after 1 year. Okay. Now, so instead of doing this, okay, and that's after 1 year, I should put a little 1 right here. Okay, that's after 1 year. Now, instead of doing this, I want to do it the adult way and do it this way. Okay. Now, if this were 9, then this would be 9. Okay, and so on and so forth. Now, let's say you want to find out how much money you're going to have after 2 years. Okay, after 2 years. Well, then this is going to become 2. Or how about I do it this? You can do it the long way, which is multiply it by another 1.08. That's the long way. Or you can just change that green 1 to a 2. That's how much money you have after 2 years. Okay. Now let's say it is, and if you want it to see how much money you have after 3 years, then you change this to 3, and so on and so forth. Okay. Now, let's say you want to find out how much money you have after n years. Okay. If you just want a formula, so this is a formula basically to determine how much money you have after however many years you want to find. Okay, just plug it in for n. If you want to find out how much money you have total after 4 years, then you plug in 4 for n. Okay, and so on and so forth. Okay. Now let's say you want to work backwards. Okay, let's say there was a problem and it asked you to work backwards. And it says, oh, hey, I want you to find out how long it takes. Okay, find out how long it takes to how long does it take to get $18,000? How long will that take? Okay, well then I'm going to set this equal to 18,000 and solve backwards for n. Okay, and we've done that before with the problem types. Basically, divide both sides by 12,000. Okay, and you will get 1.5. Okay, so you're going to get 1.08 to the power n equals to 1.5, and then you log up both sides, move over the n, and divide log 1.5 divided by, do log 1.5 divided by log 1.08, and that's your answer. Okay, and let me quickly do that just so you guys can get a sense. I'm going to do log 1.5 divided by log 1.08, and you will get 5.26 years. Okay, n is going to roughly equal to 5.26 years. Okay, so it will take 5.26 years to get to $18,000. Okay, so long story short, sometimes they ask the question of, oh, tell me how much money total you have after 5 years. In that case, you plug in 5 for n, and it spits out a different number. It spits out a number here. Okay, sometimes it goes backwards. It goes backwards like the example we just did, where it tells you the final amount. Okay, it tells you the final amount, which is 18,000 in this case, and it wants you to work backwards to find out how long it will take to get to that final amount, which in this case is 5.26. Okay, so let me rephrase the first scenario using the word final amount. So sometimes they ask you, they give you n, they say, oh, what is the final amount after 5 years? Then you plug in 5 for n, and it spits out the final amount. Sometimes they give you the final amount first, and you go backwards and find the number of years it takes to get to that final amount. Okay? Another thing I want to show you is exponential decay. Okay? So let's say we're in a hypothetical scenario. Okay? Where we're not talking about a bank now, we're talking about stocks. Okay? Now, let's say that you buy, this is a completely made up scenario. The numbers are not going to be realistic. But let's say, you give $12,000 to like a company that manages stocks for you, and you're like, hey, I got too much going on in my life to pick the stocks, to research and pick the stocks. You pick the stocks for me. Okay. What's a better example? That's actually really not a good example. Let's do this. Instead of dollars, let's talk about bacteria. Okay, so let's not talk about dollars here. Let's talk about bacteria. So let's say you have 12,000 bacteria and they die off. They decrease. Okay, 12,000 bacteria. A population of 12,000 bacteria, they decrease. They're dying at a rate of 8% per year. Okay, so let's just jump straight to the adult way of doing it. Okay, you will get, this will become instead of 1 plus, here, let me do it like this. You're going to do, after the first year, you're going to get, it's a minus now because it's decreasing. Okay. And if we were to reverse distribute, you get 1 minus 0.08, and then you get 12,000 times 0.92 n. Okay, for the number of years. Okay, so if it's decay, if it's decreasing, you do 1 minus that and you get 0.92. Okay, if it's increasing, you do 1 plus that. Okay, all right. last thing I want to show you, okay, this should be actually kind of review. You probably learned this in IM3 Advanced. If you were in my class, you learned IM3 Advanced. Okay, last thing I want to show you is this. Let's pretend it said instead of 8% per year, okay, it said 8% every 4 years. Okay, 8% every 4 years. So 8% every 4 years. Okay, so again, I want us to set up, just like we did transformations, let's give ourselves two options. Okay, let's give ourselves two options, 4/1 or 1/4. Okay, we're creating like a little multiple choice problem for us. Okay, now every 4 years is going to be less frequent compared to every year. So if it's less frequent, you pick the lesser of the two multiple choice options and do 1/4. So in this case, every 4 years, okay, every 4 years would be 1/4, 1n/4. Okay, and that makes sense because when you plug in, you need to plug in n equals to 4, not n equals to 1, 2, 3. You need to plug in n equals to 4 for this to fully decrease by 8%. Okay, so 4 divided by 4 is 1. Okay, which means, let me actually phrase it this way. This may be an easy way of phrasing it. Okay, it used to take only 1 year to decrease by 8% or multiply by 0.92. Let me use that. It used to take 1 year, okay, to decrease by 8%, but now it's going to take 4 years to take 4 years for what it used to take 1 year to decrease by 8%. Okay, so 4 divided by 4 is going to equal to the 1 that it used to be. Okay, I think I may be wording it a little bit confusing, but I think it's kind of self-explanatory. I'm wording something that's very simple in a confusing way. Okay, so I think if you just look at it, it just kind of makes sense. Let me try that again. Okay, now it used to take let me just leave it like that because I don't want to say too much and confuse you guys even more. Okay, now let's say it said every 4th of a year. Okay, instead of every 4 years, it decreases at a rate of every 4th of a year. Every 4th of a year. So that is actually going to be more frequent. That decreases more frequently compared to 1 year. Okay, it decreases more frequently compared to 1 year. So we're going to pick the bigger number, which is 4/1. Okay, so we're going to pick 4/1 in this case, which is right here. So this is going to become a 4n in this case. Okay, this is going to become a 4n. All right. Okay. All right, folks, I want you guys to do the problems that I'm going to show on the screen in a little bit.